Hello. We have a real computer outputs, like you run real projects, and I collect some vibration. Okay, this is what I collect from real projects. So probably you're gonna see the similar building vibration mode when you do your building projects. Just a little bit later. Right? Okay, this is a building, 60-story buildings, and this is 3D schematic view. This is a building view. And I don't think I'm gonna magnify it right now, but this is a three-dimensional schematic view of the building, and this is plan view. Right? We have a longer length in this direction, which is east to west, and north south is shorter. So we expect the building period with north south is gonna be longer than this, right? So which one is gonna appear in the list of the computer outputs? I guess we're going to see this building period and vibration first. This is shorter side, and this is a giving you a longer period. Okay, so here we have a first mode. As you know that we don't come across y-axis, no, nothing, right? And we have two of them, one and two. So y1 and 2, we have a this direction, we have this direction. So this is probably the building mode and vibrations with this directions, and this will probably come from this direction because this is more flexible, will yield the building period, which is longer than that of from this directions. All right, and we have a torsion. If you see the torsional mode, the torsion mode is very nice, and it's not very damaged and screwed up inside, right? We have very clean the twisting dimensions if you see inside of the building, right? And that means that the building twisting direction do not change for the first mode. As you see, this translational mode never come across the y-axis for the first mode, right? And we're going to have a little different situation when you see in the second mode. This is second mode. Why? How do you know this is second mode? If you plot the vertical axis, you are coming across the y-axis once. So this is a 2 minus 1, which means that this is a second mode, right? Second mode of which direction is probably the flexible directions, this directions. And this is another second mode from the other directions, which is more stiffer than the other directions. Very easy to follow, isn't it? And this is a torsional mode again, but this torsional mode would change the twisting direction once. So if you see inside of twisting mode, it's a little more complicated and the lines are a little more dirty, right, than this one. Because you are changing your twisting direction, go this way, and then you're changing your twisting direction somewhere, maybe 30 floors in the building. I don't know. You have to take a look at it in your projects of your buildings, but this is what I guess. Okay, and this is how many mode we come across twice, right? So this is third mode, n minus 1 theory, right? So this is third mode for the flexible directions, and this is third mode for stiffer directions, and this is another twisting mode. How many times of twisting direction has been changed here? We change it twisting direction twice here, probably, right? As the y-axis has been crossed out twice with the translational mode, horizontal mode right there. So inside of the twisting mode, it's very complicated. You don't even take a look at here because all the line here very dirty, right? So and so on and so forth. So you can go this forever. So you cannot go forever because the computer times takes, and then the computational money cost is very expensive in some cases in reality. So we have to terminate in some number of period. Like for example, you can order a computer to stop with 100 mode and 200 mode, right? So I'm gonna say that again in the future lecture, but what we are doing right now is that we're gonna ask the computer to stop calculating this mode when the computer catches the 95% of the energy that this building is gonna dissipate, right? For example, as I told you, the first mode, this mode is gonna be the mode which needs a lot of energy to perform, to execute with the first mode, right? And second mode needs another fraction of energy to execute in second mode, and so on and so forth. So all the mode will need a energy, and it needs to dissipate energy as it goes along with from lost mode to iced mode. All right. So we're gonna ask computer to stop calculating mode shape anymore when 95% of energy has been dissipated, has been used up. Right, then stop it. Right, we don't want to go forever. Right, you can go forever because there's a lot of degrees of freedoms. I'm not going to go into the degrees of freedom theory because it's not necessary just for you right now. Anyway, we don't want to continue to hundreds of hundreds of the building mode to calculate. We're going to stop him ordering computer to stop when 95% of energy is used up. All right, don't forget 95. Right. So when you go and do minus, then we'll have to put that number for sure. Otherwise, your computer will never stop, and you wonder why. Right. Okay. And this is the okay. I want to go through this building behavior in terms of deformations a little bit before we stop lecture today. The tall building has two types of deformations. Two types of deformations here and here. Okay, this is most common types of deformation that you will see with a tall building. Tall building is very thin, and thin means the aspect ratio. Aspect ratio is the ratio of building height over building depths. This is building height. This is building depths. So building height and building depths ratio is called the aspect ratio. Aspect ratio. So this aspect ratio reaches about 7 and 8 for modern buildings right now. You see, you feel like this is very skinny building, right? Thin building. And that type of building will display the cantilever actions. We call that cantilever actions, or we call this fractional actions. Fractional actions. Okay, say fractional mode are like 95%, and sure portion will only take 5%. Whereas your short building and lower short building, your aspect ratio may be less than a gamma or whatever aspect ratio less than 5 or 4 or 5. Right? This is very chubby building and short building. Then you will see the shear deformation dominant. Okay, this is a cantilever fractional deformation, right? This is mostly high-rise building. If you see a chubby building, then you're going to see this more the dominant. It's like a shear deformation, as all we understand from that deformation pattern. So this is a shear deformation is 50%, and the rest probably 50% contributed by the fractional passion. So all this building has two types of building deformations. And we understand that right now, and we're gonna use this concept when we will detail the building design later with Midas. Okay. Any questions? Don't hesitate to leave inquiries and questions in eCampus or send me an email. It's getting complicated as week goes by, and don't be please left out. Okay. And also we have a video clips for Midas learning and Friday, Thursday clips, and I'm making that video clip very tough, right? Makes the video clips that will help you as much as you can on your own. Actually, you don't need a instructors. The video clip can instruct you to learn the Midas. The problem is that you cannot go to CalLab. That's the only problem, because without running a computer with you, it's not really easy, even if you are having a good instructors, right? That's the problem. But don't worry about it. Just take a look at the video right now, as carefully as possible, as closely as possible, and as long as the CalLab's open, you can go anytime you want, extra times, and you'll probably go a crash time and extra time with the clips, and we'll get you right there very fast, very easily. Trust me, okay? But you have to study it. Without studying it, what I said will not work. Thank you very much. And we have like 20 something minutes left, and these video clips are long. Actually, I found that its video clip contains a lot more contents than the contents that I gave you in the class in the previous years, because we don't have to call on attendant. We don't have to, I don't have to try to get attention from you in the class and all that. So these video clips are very fast and effective in terms of teaching you the contents, right? So you want to pause in the couple of times in the middle of the video clips, like 20 minutes, and pause and review and study like 10 minutes, something like that. So you want to spend like 20 to 25 minutes as a review of this video clip, right? You don't have to wait until the end of the video. You can stop in the middle and replay it and all that to get ready before you go further, right? So I'll give you a 20 something minutes for you to pause and review. Thank you very much. See you in next clip.